Evening, guys, and welcome to tonight's Drayton live training. It's been a while for me. I haven't done one for getting on for a month now. So I thought tonight we would have a look at how we can get the most out of our heating controls. Now, it may sound like a bit of a simple subject, but the reason I'm doing it is because it's really what I've seen from sort of out on site, and it's the sort of questions that the customers ask you, which I sort of think, well, it's sort of a given, really, but it's possibly that I'm just a little bit too close to it. So I don't really see it. So what we really want to do is, it's not all about upgrading your controls, although, if you've got real archaic stuff, then, certainly that's something that you need to consider. But there's a few things that we can do to keep the sustainability message going and make sure that we're doing all that we can with what we've got, as well as sort of trying to get into a new sort of mindset as we move towards things like lower flow temperatures and things like air source heat pumps, because if it's going that way, we've naturally got a lower flow temperature, so it's quite good if we can start to get on that, really, even we can do that with our existing boilers and get into the swing of the way, of having these lower temperatures flowing in our system, so that when we change to an air source heat pump or even a ground source heat pump or anything where we're forced to have a lower temperature in order to have any sort of efficiency, it's not such a big shock to the system and not such a step change. So I've got a bit of a slide deck here that I will just share with you tonight. And there's a few questions that have come in over the last few days yesterday since I did the promo. So I'll go through those at the end. If you've got any questions as we go, then carry on and stick them in the comments, and I'll endeavour to get to them at the end. But really, what I want to try and do tonight, this is the sort of thing that we're going to be covering, is obviously we're going to be looking at things like 𝗿𝗀𝗁 and the new 𝗫𝗍𝗫, which is our smart connected and our smart controls. So these are the controls that have got load compensation. But also having individual room control. Now, we know about 𝗿𝗁𝗁, how you've got multi-zone control, but it doesn't have to be a connected system where all the heads are talking back to a main controller. Just having TRVs can make quite a significant impact. And I'm going to be sharing with you these stats. So these are from 𝗵𝗲. So this is stats. A lot of this has been done at Salford University. They've got the Energy House there, where they put these sort of things through their paces. So I really just want to break down what this is all about, because there's a lot of information there. But essentially what we're looking at is, everybody will recognize the sort of RTS range on the left there. That's an energy class 1 thermostat. So what you want to be looking at here, and to get your 12% saving, is you want to be moving away from a class 1, which is essentially an on-off. So, the temperature rises, it hits set point, it turns off. The inertia from a heating system is probably going to overshoot that, and then it will start to undershoot. Now, the RTSs have got things in them. They've got like compensators and things. But the idea of just a dial thermostat, there's key savings that can be made there by moving across to something where you're setting time and temperatures. I mean, that's really your best. But even if you move to something, say, like the 𝗫𝗍𝗫 Plus, where you've got a control algorithm in the background there, which is modulating what the core for heat is. So you want to be moving away from anything that's like class 1. I think 𝗿𝗁𝗁 is a class 7 energy class 7 product. So when you have a look at the data sheets and the catalog, you just want to be a bit mindful of what the energy class rating is, because that will give you a good indicator of how much really of that 12% saving you can make by upgrading from, say, an on-off control to something that's got some intelligence, some load compensation. So the next one is individual room control. Now, when I first heard this, I immediately thought, oh, 𝗿𝗁𝗁 smart TRVs? But it doesn't actually mean that. It means just having individual control in the room. So you're not reliant on just a timer and a room stat to control your heating. You've got individual room controls by way of TRVs. Now, it's highly likely that these are going to be mandated. But there's a possible 19% saving if you fit just standard mechanical TRVs to your system. Obviously, if you go for the 𝗿𝗁𝗁 smart TRVs, then you've got that saving, but you've also got an added level of comfort where you can go through and you can set each zone differently should you wish to. So, but when you think about it, you always assume that people have got TRVs, but the number of houses you go to and you see that they've got it's incomplete, or that they're not bothering with TRVs and they're just letting it bounce either on the room stat or the timer. There's quite a significant saving to be made there, and this all really plays into the fact that obviously there's the whole green agenda where we really need to be reducing our usage. But I think really what's going to drive that is the fact that the energy prices are set to rise by estimates of up to 50%. And that's normally what gets people going if it starts to cost them more money. So you can see that, by relatively low investment, by using mechanical TRVs, you're able to get quite a significant saving, particularly if your energy bills are going to rise. And then the last one is a 6% saving if you move away from just time and temperature control. Now remember, to be L compliant, you've got to have time and temperature. But if you can move across to something which has got load compensation, whereby you're able, you've got some modulation there. And this is really what it's all coming down to. We don't want to have the boiler on until we hit set point and then off, because all you'll do is you'll get a really big temperature swing. We need to, if we're going to control in that way with relay control, we've got to chop up time and then we've got to modulate. Now the boilers will do that as well. They generally stop you from short cycling them. But what we really want to do is we want to look at the demand that is being generated, and this is really what WISER does. It will convert the demand, the percentage demand, into an output, and that will be translated into time. So depending on what cycle rate you have, and that's something I'll go through in a minute just to show you, because again, picking through people's systems that are not necessarily getting the best out of it, that's one of the things I always check is it set up for the right type of boiler. So it's difficult really to talk in terms of what this actually means in terms of numbers, but average cost of energy there, the dual fuel plan is 1138, 542 is typically what you'll pay for gas. But remember that could be about to rise by 50%. So all the stuff that we're talking about here about trying to get to drive as much efficiency out of our heating systems is as much about what we can save in terms of money, as well as what we're trying to do to be more sustainable and make sure that the resources that are being used most effectively, and we're reducing the total through not having so much wastage. So another one that's a common thing, something that's getting a bit more momentum now, is flow temperatures. So you've probably like I alluded to at the start there, when we start looking at moving over to any sort of heat pump, then the flow temperature is dramatically reduced. It doesn't have to be, but if you want to drive anything like a 300% coefficient of performance, you need to get your flow temperature down much further than what we would typically have with a gas boiler. But that said, you can still drive more efficiency out of your gas boiler if you drop your flow temperature. So you can see this graph here. Now, the important thing is we always want to try and strive to have our return temperature below the dew point, which is 54 degrees, because if we can ensure that what's coming back to the boiler is below 54 degrees, the boiler will run in condensing mode. And that's where we can then start to push the efficiencies up sort of around 89 into the 90-odd%. So the more we keep it outside of the hotter, if you like, our return temperature that's coming back, the less efficient our condensing boilers are going to be. But you can see here, I mean, most people sort of have their flow temperature around, maybe 65, 70 degrees, but that's giving you probably, assuming you can get your delta T of around about 20, where it's going out at 70 and coming back at 50, so you're below that 54, you're going to get an efficiency of around about sort of 86, 87%. If you can drop that back, so if we're looking at the sort of golden figure there of about 55 degrees, you can see you can start to really ramp your efficiency up, and the cooler that you can have your flow temperature coming back, the more efficient you're going to be. So this sort of sets the scene. If your customer is not necessarily going to move over to a heat pump right now, but obviously if that's the way the technology goes in the future, then we need to sort of manage their expectations, where they're not going to have steaming hot radiators. You don't really want them ringing you up saying, I don't think the heating system's working because the radiator's not steaming hot. We need to try and change that mindset. So we can do that by just dropping down the flow temperature on our boiler, which again will result in a lower return temperature, and that's really going to boost your efficiency. But overall, we've got to really keep the return below 54 degrees. And I'll come back to this a little bit at the end with one of the questions that has been asked since I put the promo video out. But again, easy thing to do, doesn't cost any money, you're not having to fit anything, but it really, a graph like this really brings home how by just knocking, say, 5 degrees off of your flow temperature that's leaving the boiler, that's going to then impact the return temperature, and then what that's going to do to your efficiency. Now, on to the product. So that's really what you can do, by sort of choosing the appropriate product. Once you've got something, say, like 𝗿𝗍𝗳 or installed, or indeed the new ☽𝗿𝗀𝗳𝗏, because again, the same applies. If we're using load compensation, so we're connected via the relay terminals. So you're going to be using the relay terminals on the backplate going out to drive whatever it is, maybe direct connection to the boiler if it's a combi, or through a suite of zone valves if you've got that sort of system. But the important thing I'm going to draw your attention to here is where it says the source type. Now, we've got it set as a gas boiler. Now, a lot of people don't, if you don't do anything, it stays defaulted at gas. Now, your options in there are oil, gas, electric, and heat pump. And what that does is you're not just aligning it to whatever boiler that you've got. What you're actually doing by defining those parameters is you're saying the cycle rate. So you're determining the cycle rate of your modulation. So like I said before, we're the way that we control so that we don't just have the boiler on until we hit set point, and you get a massive overshoot, and then it starts to drop, and you get this really big swing around about set point. The way we stop doing that is we don't have the boiler on all the time. So we've got a thermal profiling that's going on within the control. So it's learning how quickly the room or the environment that's in gains or loses heat. But then coupled with that, we can then modulate the boiler based on time. So when you're controlling by relay control, your boiler stat is fixed at a temperature 65, 70 degrees. So we can't change that with the control. What we can change is how long it's on for, and that will overall bring the temperature down. So if you've got it set for gas, what that means is the hour is split up into 6 lots of 10 minutes, and then the control will work out how long in each of those 10-minute segments, the boiler needs to run for in order to fulfill set point. Now, that could be anything from 1 minute, or it could be off completely. So if there's no demand, it won't run at all. It can't run any less than 1 minute, but it could go anything up to 10 minutes. So if you're trying to ramp up from a really cold ambient temperature, it's likely that for the first 10-minute block, it could be on for, say, 10 and 10. And then when it gets to the next one, it will say, all right, well, I don't need to be on for that much time now. So it might drop to 8 and then 6. But ultimately, what we're doing is we're working out how long in each 10-minute segment the boiler needs to be on in order to achieve and maintain the set point of your choosing. Now, that thing about 6 lots of 10 minutes within the hour, that is for a gas boiler. If you change it to oil, your 10-minute slots become 20 minutes. So it's a much slower system. So what you can expect to have is your boiler on for longer and off for longer, but that's more suitable for an oil boiler, because there's no point having an oil boiler kick in for 1 minute, because by the time it works out what's going on, the core for heat will have died. So that's not going to work for an oil boiler. So you need to have longer burn periods. But the problem is, if you have that, or if you have it set for oil on a gas boiler, you're going to have 20-minute blocks, so your boiler is going to be on for longer, which is more chance for it to overshoot, and then the off period is going to be longer, so it's got a little more chance for the temperature to drop. So again, you're swinging around about your set point, which is what we want to get away from. We want our control to be as tight to set point as we possibly can. Similarly, for an electric boiler, which is another option in there, that's 12 cycles per hour, so once every 5 minutes. Much too fast for a gas boiler. Your gas boiler will prevent you from, if you set it up for that, it'll highly likely that it will have short cycle prevention kick in, so you won't get anything. You won't get any heat out of it. but obviously for an electric boiler where you've got instant on-demand heat, it's ideal for that. And the other setting is heat pump in there, and that's an on-off setting. So remember, for a heat pump, we don't want to be turning it on and turning it off and turning it on and off, even though the controls aren't actually turning the heat pump off. All the heat pump needs to know is the demand, isn't the demand. So for that, the on-off control is very much rather like what an RTS would be. So it's on until you hit set point, and then it's off until you drop below. But that's what you would need for a heat pump. But it's really important that you get the appropriate setting in there in order for you to have the best efficiency. If you've got a gas boiler and it's set to oil, you're not going to be driving the system as efficiently as you could. So that's one that I tend to pick up because people sort of skip over it. You sort of find out if they've got an oil boiler and it's set to gas, people tend to find out quite quickly about that because it doesn't tend to work very well. But if you have it the other way, if you have it set to oil and you've got a gas boiler, you won't really notice any loss of comfort, but you aren't really controlling as it should be. So the next one is the effective use of the smart elements of 𝗲𝗍𝗀. So we've got away mode. So I'll just take you through what away mode does. So this is a quick way of setting a blanket temperature across all of your zones. So remember, with 𝗲𝗍𝗀, you can have up to 16 zones. Now, if you leave the property, you don't really want to have to go in and set all 16 to a lower temperature individually. So with away mode, you go in and you define the profile. So you say, I want this temperature to be applied across all of my zones when I activate away mode. You can choose whether the hot water is part of that or not. And you can also choose whether the smart plugs are part of that as well, which they may well be, or they may not. You may want them to operate outside of away mode. But ultimately, you go in, you define your profile, and then when you go into the automation page on 𝗲𝗍𝗀, you can toggle it on. So the effective use of away mode, which is you leave the house, you toggle it so that all your temperatures drop down. When you come back, you toggle it on, and they all go back to either following the schedule or manual mode. The effective use of that has the capability of saving you 24%. Again, this is 𝗵𝗲stats. And the other smart modes that we've got are eco mode and comfort mode. Now, eco mode is essentially weather compensation, but you're not using a weather compensator that's sort of screwed to the wall outside, not a physical one on the system. This is based on weather data. So when you register your postcode and you register the system, it feeds in weather data based on that postcode, and it will then make changes to the back end of your schedule. So it's like optimal stop. So the system with normal thermal profiling, if eco mode is disabled, if your heating's going to be on, or say 20 degrees until 5 p.m, and then it drops back to say 16, the control knows that it doesn't need to keep the boiler on right up to 5 o'clock. It may be that it can kick out by, say, 10 to, and then the inertia will ensure that you retain 20 degrees until 5, and then it will start to decay away. If you then engage eco mode, it will then just apply some sort of like an offset based on the weather. So if it's particularly cold outside, it may be that it would normally go off at, say, 10 to 5. It may stay on until, say, 4:52. Or what you tend to find is as you progress towards the summer and the ambient temperature outside gets warmer and warmer, your off time gets earlier and earlier each day. So you're still maintaining 20 degrees up until 5 o'clock in this particular example, but it's not because the boiler's been driven on. So it's a nice way of just being able to automate your system. The other one there is comfort mode. Now, you've got to be a bit careful with comfort mode because comfort mode is designed to take the guesswork out of your schedules. So whereby if you want your heating to be on, or you want to get up at 7 o'clock in the morning, you would arbitrarily set your heating to come on maybe at 6:30 now. What comfort mode does is it works out when it needs to come on, which can be a good thing as long as you don't have your set point set too high. So before you use comfort mode, what you really want to do is you want to go through and find out what temperature is comfortable for you in each of your zones. Now, don't just think, oh, well, I used to have my old dial stat at 21 degrees. That's what I like. You want to start at about 19 degrees. And then if that's too cold for you, just increment up in half-degree increments to find what your comfort temperature is, what you're happy with. And then you can engage comfort mode. So it means that instead of your heating just arbitrarily coming on half an hour before you want to get up, it may be that it doesn't need to. It could come on, say, at 22 or quarter to, in which case you've saved yourself that amount of heating in terms of both money, but also in terms of fuel burn. So comfort mode is really useful tool. You've just got to, particularly with the customers, you've got to manage their expectations, because if you set it to, say, a really high temperature, it's highly likely that it will come on before they were expecting it to, because ultimately what it's saying is, by this time, I'm going to make sure I have the room at this temperature. So got to be careful how you use comfort mode, but it can be a really good tool. If you use eco mode, your savings in the region of around 7%. Now, so that's really that's the changes that you can make to try and reduce your usage. What really makes a difference here is being able to see what you're using. So you make the changes, you really want to be able to see what effect those changes have. So all of our systems, or all of the WiSER systems that is, have insights. So if you go into the insights page, it gives you a readout just to show you what your usage is, and it talks in terms of boiler hours. So you can see how many boiler hours you've used in a particular period, and it will tell you how much, by having eco mode engaged or enabled, how much you will have saved by, or how much that facility will have saved you. But you'll see there's a little thing at the top there which says Unlock Insights Plus. Now this is something that we've launched recently, which is how you can link this to your smart meter. So rather than talking in terms of boiler hours, which is a little bit of an arbitrary unit, what we really want to understand is how much did that heating period cost me? How much gas or whatever fuel did I burn in that period? So if you've got a SMETS2 or compatible SMETS2 smart meter, you can go through and you can unlock Insights Plus. So you need to buy a little in-home controller, that you see there. That's the 𝗫𝗷. So 𝗫𝗷 are the service provider that we use, and that's sort of the bridge between the the data that's coming in from the smart meter and the data that's being held on the cloud with your WiSER system. But you go through the Schneider shop, and I think last time I checked it was $14.99, but the prices may have changed. But that's what it was last time I looked. But you go through and you purchase this in-home device, and that will then, and through the WiSER app, you can go through and set this up. But what it essentially does is, rather than talking in terms of boiler hours, it looks at what your tariff is, it looks at what your usage is, and you can see exactly what your usage is and how much it has cost you. And there's other things in there like budgeting, to make sure that you can set budgets. It will tell you that if you drop your temperature by X amount, you're likely to save this much money. So it's a really, really nice tool if you've got a compatible smart meter that you can use the 𝗫𝗷 in-home device on. Then it's a really good thing, and it's a really nice thing to sell to the customers. We've got to move away. If customers say, if the customer says to you, what's WiSER all about, you don't really want to be saying, oh yeah, well, it's a heating control that you control it with an app. It absolutely is that, but what we're trying to do here is we're trying to manage home energy, and that's really what sets us apart from the competition. We are trying to manage our home energy to make sure that we're using the least amount we can, but not at the expense of any comfort. And that really brings me on to this last slide, which is sort of what the WiSER project is all about. So we obviously talk very much about the heating solution here because we are Drayton, but WiSER is a much bigger brand within Schneider. And you look at this home here, we've got all sorts of things going on here. We've got PV and solar, we've got EV charging. So you think, well, what's WiSER got to do with that? Well, this home energy management system that you see in the center, which is an integral part of this system here, to manage all of the different things going on in the home, that essentially is what WiSER is going to become. So like I say, whilst we're looking at the heating load, and heating is one of the most expensive things you can spend in terms of energy cost in the home. This is why, by having it on the WiSER platform, ultimately you're going to be able to manage all of these different things through the home energy management system, which is WiSER. Now, I'll come on to the questions. So a question came in. Let me just refresh my memory on this a minute. So a question came in on the promo video yesterday. And it's with regard to priority domestic hot water. So everybody, I'll just give you a bit of sort of background on what this is. So everybody's sort of familiar with things like S-plan and Y-plan systems, where you've got motorized valves controlling flow into the different circuits and consequently firing the boiler. Now, the problem is that those sort of systems are a little bit archaic in so much as they're left over from when we used to have non-condensing boilers. But again, this thing about having your return temperature below 54 degrees below the dew point is fine pretty much for your central heating system, because we spend a lot of effort trying to balance the system. And what we're trying to do there is we're trying to make sure that all of the radiators are pretty much the same resistance to flow, so that the water that's leaving the boiler on the flow, is emitting that heat into the room effectively. It's not being robbed by any one particular radiator, and then it comes back on the flow with a delta T of about 20 degrees. Now, the problem we've got with say something like an S-plan system is most installers don't tend to bother putting any sort of valve to throttle down the flow on the return from the hot water. So when you call for hot water, the flow tends to race through the indirect coil in the middle of the cylinder, and before you know it, before the cylinder is actually up to temperature, you've got the flow and return, or the return is up close to the return is up close to what the flow is, which again, if it's above 54 degrees, we're immediately in that non-condensing state, so things aren't working very well. So the priority domestic hot water again, this is a system that's sort of early versions of this were called W-plan systems. But what we're essentially trying to do here is we want to have the ability to have two separate flow rates from the boiler. So you want a low flow rate for your radiator circuit, but when there's a core for hot water, you want that to ramp up. Now, to do that, you've got to have obviously a boiler that's going to support that, but you need to have this normally open zone valve. If you think of all of our zone valves now, they're all normally closed. You de-energize them and they close. To be able to do an effective X-plan system, you need to have a normally open zone valve. So to answer your question, no, we don't support that at the moment, because we don't do a normally open zone valve. But I suspect that we're going to have to, because these systems are going to become more prevalent, because it's all very well having, say, 40-degree water running around your radiators and keeping the room nice and warm, but that's not going to suffice your hot water cylinder in terms of having hot water that's at the temperature you want, or indeed for Legionella control. So I think what we're going to see is much more prevalence from boilers that are going to have two different flow temperatures, or the capability to give two different flow temperatures for two different circuits. And the consequence of that is obviously you need to have the controls that are able to support that. So at the moment, I guess you could probably rig it whereby you sort of invert your control theory so that you keep a normally open valve or normally closed valve open all the time, but it's certainly not an elegant way of doing things. So I hope that answers your question. Not at the moment, but I'm pretty sure that that's going to be something that we will be looking at as these different types of systems, as we move away from the traditional S-plan and Y-plan. Now, you may have noticed that I've haven't really mentioned OpenTherm all the way through what I've been talking about tonight in terms of energy efficiency, because there's some. I'm sure if you've been on the group, you've probably seen the comments that have been made about OpenTherm. So I really just wanted to clear up what's going on with OpenTherm in terms of predominantly 𝗿𝗎𝘁, really. So 𝗿𝗎𝘁 is OpenTherm compliant. In so much as we are part of the OpenTherm Alliance. So despite its name, in order to be able to produce these products, you've got to be part of the OpenTherm Alliance. And 𝗿𝗎𝘁 is OpenTherm compliant in so much as when you call for heat, the percentage demand that's calculated by the hub is converted into a flow temperature that's requested from the boiler. So so the intergas boilers that we've got here that we developed this with, that works absolutely fine. You call for your demand fluctuates the flow temperature based on the parameters that you set on the boiler. Now, the challenge that we've got at the moment is that a lot of boiler manufacturers now have set their boilers up whereby they're OpenTherm compliant, but as soon as you connect an OpenTherm control to it, it locks out the panel on the boiler with the expectation that all the stuff that you would be doing on the boiler panel, you can now do from within the control. And that's where we get the issue, because obviously you can't. So things like setting your flow temperature for your, particularly on like a combi for the hot water, the challenge that you've got there is you can't set it on the boiler panel anymore. Now, again, this is not for all boilers. This is just some boilers that have this mechanism whereby their onboard panel is locked out when an OpenTherm control is connected. So it's not across the board, but the issue is that you can't set the flow temperature, and so what it does is it just ramps to maximum, which obviously is not particularly efficient, and also it means that you get steaming hot water coming out of your taps, which is far too hot. So you're in some ways you're forced to blend that back down. Now, we are committed to being OpenTherm compliant because it's clearly a future technology, and you can see just from the graphs there, with the best will in the world, the relay control that we do by modulating time certainly gets you close to set point, but what we're really going for here is low and slow. This idea of instant heat where we want to try and get a room warmed up as quickly as possible. If we want to do that efficiently, then we can't really do that. We need to have constant a constant low temperature, which obviously OpenTherm supports, because we've not got a fixed boiler stat. But it doesn't work if you can't get in there and change the parameters. So it's something that there's a lot of discussions going on here about what we do about this, and it's sort of been a development that as this technology has got into more and more boilers. It used to be that it wasn't particularly prevalent, but it now just seems to be becoming a standard whereby you lose functionality of the boiler, the onboard boiler panel, if you connect an OpenTherm control. So it's something that we certainly need to work on. And like I say, we are committed to being OpenTherm compliant. So it just needs a bit of engineering resource from our end to get this up to speed. But you can rest assured that we are doing everything we can here in order to make sure it is going to work. And like I say, it's not across the board. We are, in some ways, we're collating a list of boilers that we know we've got problems with, in so much as those that lock out the onboard panel when you connect an OpenTherm control. It's not across the board, but certainly it's something that does need some work by us, and it's something that we are on. So let's have a look and see if there's any more questions come in tonight. I don't think I don't see anything immediately that's coming in. There is a question here regarding, is there going to be a rerun of the standard range of stats and timers? I don't think we've got that scheduled. However, I think that it should be up on YouTube. So I'll have a look back through. So what tends to happen with all these live streams that go out, they'll go up onto the group after I've finished, and then we pull them down. We sort of top and tail them and get rid of all the dross, and then they go up on YouTube as a resource for you. So what I'll do, I'll have a look through, and I'll see if it's up there already, because it should be, because all the ones I do should find their way up there. If it's not, I will certainly put it up there, and I will send you a link to it, so you'll be able to rewatch that. But certainly not planned, but that doesn't necessarily mean it isn't going to happen. Any more questions? I don't see anything. Well, thanks for joining me tonight, guys, and I hope that's cleared up a little bit about particularly OpenTherm, because I see that there was quite a lot of quite a lot of activity on the group about that recently, and I certainly understand where you're coming from, and it is certainly something that we need to look at. But just rest assured that it is in hand, and we're doing our best. Thanks for joining me. I think the next one of these is again in about a month's time. But again, if you've got anything that you want me to cover particularly, just stick it in, comment on any particular video. They're all monitored, so stick it on any video, any comment, and I'll do my best to accommodate what you've got. Thanks for joining me, guys. I hope you have a good evening. I'll catch you soon.